You've probably heard of the Big Bang as the beginning of the universe as we know it. However, scientists have been discovering what happened before the Big Bang. They have been limited by the proper instruments for their research, but a new tool, the James Webb Space Telescope, has joined the stable of telescopes that scientists have access to. In this video, we'll show you the terrifying new discovery of the James Webb Space Telescope about the time before the Big Bang. If we must know the present, we must understand the past. This truth applies to humans' quest to understand how the universe started and, ultimately, the meaning of life. However, looking back in time is difficult because it involves billions and billions of years. Successive space telescopes had gradually got us closer to the Big Bang, but they just didn't have what it takes to show us the Big Bang, making it impossible to tell what came before it. But that is no longer the case, as we may have a new eye in deep space, known as the James Webb Space Telescope. Thanks to many breakthroughs, some of them very risky to implement, we can now look 13 billion years into the past and see just when some of the stars were being formed. Scientists are looking forward to about 2 decades of scanning deep space to unlock the deep secrets of the universe with the JWST. But that will only come after NASA engineers have concluded calibrating and configuring the different instruments on the Space Telescope. The work on this has progressed, and all the mirrors of the JWST are now acting as a single unit. It recently sent back images of a star that is being used for the setup. We are just a few months away from the first working images of the JWST. It will help astronomers detect more exoplanets and search for signs of life on them. However, finally, we will be able to unravel the mystery of what happened before the Big Bang. But before we go to what took place before the Big Bang, what exactly is the Big Bang? The answer is essential because there are many misconceptions about what that momentous event in the history of the universe is. There are several theories trying to explain how the universe started. They include the steady-state universe, which denies the possibility of a beginning and end for the universe, but says the universe is continuously expanding while still maintaining the same overall density. In other words, a steady-state universe is forever identical, but continually growing bigger in scale. In this model, galaxies, planets, and other forms of matter are locked in continual recreation. Since the density remains the same, old astronomical objects become unobservable as new creations take their place. Another competing theory is the bouncing cosmology or Big Bounce model, which says the universe shrinks to a minimum volume and then bounces back into a subsequent expansion. There is no shortage of theories of how the universe began, so there is the plasma or electric universe model. Plasma is the word given to the fourth state of matter, that is solid, liquid, gas, and plasma. A plasma is a gas that is so hot that some or all of its constituent atoms are split up into electrons and ions, which can move independently of each other. In plasma or electric universe theory, plasma takes up an integral role in cosmological events and the fundamental order of the universe, proposing electric currents that flow along plasma filaments capable of shaping and powering galaxies. These currents stream into stars, powering them like fluorescent bulbs and inducing the births of planets. There are more theories about how the universe began, but the most popular one is the Big Bang, and you can thank the popular TV show The Big Bang Theory for bringing it further to the masses. It is also the most widely accepted in the scientific community. This theory was born of the observation that other galaxies are moving away from our own at great speed in all directions, as if they had all been propelled by an ancient explosive force. A Belgian priest named Georges Lemaitre was the first to suggest the Big Bang theory in the 1920s, when he theorized that the universe began from a single primordial atom. The idea received significant boosts from Edwin Hubble's observations that galaxies are speeding away from us in all directions, and from the 1960s discovery of cosmic microwave radiation, interpreted as echoes of the Big Bang by Arno Penzias and Robert Wilson. Further work has helped clarify the Big Bang's tempo. Here is how the Big Bang went. In the first 10 raised to the power of minus 43 seconds of its existence, the universe was very compact, less than a million billion billionth the size of a single atom. It is thought that at such an incomprehensibly dense, energetic state, the 4 fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were forged into a single force. Still, current theories haven't yet figured out how a single unified force would work. To pull this off, we'd need to know how gravity works on the subatomic scale, but currently we don't. By the time the universe was a billionth of a second old, the universe had cooled down enough for the four fundamental forces to separate from one another. The universe's fundamental particles also formed. It was still so hot that these particles hadn't yet assembled into many of the subatomic particles we have today, such as the proton. As the universe kept expanding, this piping hot primordial soup, known as the quark-gluon plasma, continued to cool. Some particle colliders, such as CERN's Large Hadron Collider, are powerful enough to recreate the quark-gluon plasma. The radiation was so intense in the early days of the universe that colliding photons could form pairs of particles made of matter and antimatter, which is like regular matter in every way except with the opposite electrical charge. It is thought that the early universe contained equal amounts of matter and antimatter, but as the universe cooled, photons no longer packed enough punch to make matter-antimatter pairs. So, like an extreme game of musical chairs, many particles of matter and antimatter paired off and annihilated one another. Some excess matter survived, and it's now the stuff that people, planets, and galaxies are made of. Our existence is a clear sign that the laws of nature treat matter and antimatter slightly different. Researchers have experimentally observed this rule imbalance called CP violation in action. Physicists are still trying to figure out exactly how matter won out in the early universe. While scientists talk with confidence about what happened after the Big Bang, what exactly took place before the Big Bang? We will soon get to that after answering these two interesting questions related to the Big Bang. Where did the Big Bang take place? When a stick of dynamite explodes, the detonation occurs in one place, and shrapnel flies into the void. However, in the Big Bang there was no center and no pre-existing void, so it didn't happen at any location per se. Space itself popped into existence and began expanding everywhere at once. Some astronomy books compare the universe to a rising cake, with raisins representing galaxies. As the cake grows, raisins recede from each other with no center of expansion, just like the Big Bang. But, of course, a cake has an edge, unlike the universe, which may go on forever. In the real sense, no analogy can perfectly capture the Big Bang. Also, was the Big Bang a one-off? Well, at the beginning of the Big Bang, there was the inflationary vacuum. When it doubled its volume, it doubled its energy. When it tripled its volume, it tripled its energy. If banknotes were like this and you pulled apart a stack, ever more would appear. Physicists call inflation the ultimate free lunch. The inflationary vacuum expanded ever faster, but it was a quantum thing, and quantum things are fundamentally unpredictable. Randomly, all over the inflationary vacuum, parts of it decayed into an ordinary, everyday vacuum. So what happened before the Big Bang? It's possible that before the Big Bang, the universe was an infinite stretch of an ultra-hot, dense material persisting in a steady state until, for some reason, the Big Bang occurred. This extra-dense universe may have been governed by quantum mechanics, the physics of the extremely small scale, Carroll said. The Big Bang, then, would have represented the moment that classical physics took over as the major driver of the universe's evolution. What did Stephen Hawking have to say concerning the Big Bang? Before the Big Bang, he said events were unmeasurable and thus undefined. Hawking called this the no-boundary proposal. Time and space, he said, are finite, but they don't have any boundaries or starting or ending points, the same way that the planet Earth is finite but has no edge. Since events before the Big Bang have no observational consequences, one may as well cut them out of the theory and say that time began at the Big Bang, he said in an interview on the National Geographic show Star Talk in 2018. Or perhaps there was something else before the Big Bang that is worth pondering. One idea is that the Big Bang isn't the beginning of time, but rather that it was a moment of symmetry. In this idea, prior to the Big Bang, there was another universe identical to this one, but with entropy increasing toward the past instead of toward the future. Increasing entropy, or increasing disorder in a system, is essentially the arrow of time, Carroll said. So in this mirror universe, time would run opposite to time in the modern universe, and our universe would be in the past. Proponents of this theory also suggest that other properties of the universe would be flip-flopped in this mirror universe. For example, physicist David Sloan wrote in the University of Oxford Science blog that asymmetries in molecules and ions, called chiralities, would be in opposite orientations to what they are in our universe. At any rate, another theory holds that the Big Bang wasn't really the beginning of everything, but rather a moment in time when the universe switched from a period of contraction to a period of expansion. This notion suggests that there could be infinite Big Bangs as the universe expands, contracts, and expands again. Let's hear what you think of the Big Bang Theory in the comments section below.